Hello, everyone. Thanks for joining. I'm just going to wait a few minutes or a few seconds while people are logging in. All right, so thanks for joining our webinar today, Navigating the Data Maze. My name is Jordan Leibovitz, and I'm part of the marketing team here at IMO. Before we get started, I want to take care of a few items for those attending. First off, this webinar is being recorded and will be available to you after the webinar. Throughout the session, all attendees will be in listen-only mode, but if you have any questions during the webinar, feel free to put them into the Q&A box, and then we'll address them at the end during our Q&A session. The agenda for today is going over the challenges across the data lifecycle, a tool explanation of capabilities, how it works in practice, and considerations for investment and implementation, all through the lens of data normalization, natural language processing, and value set management. We have two speakers from IMO, Hao Ding and Mamta Mishra, both our product managers here. And so without further ado, I'm going to pass it over to Mamta.
Hello, everyone. I'm Mamta Mishra. I'm a product manager here at IMO. I've been with IMO for around 2 years now. I'm responsible for the value set management solution, which we refer to as IMO Precision Sets here at IMO. So IMO has been around for almost 30 years now. We are based in Rosemont, Illinois. IMO has powered data capture at the point of care with comprehensive clinical terminology and code mappings. That's what we do. So this allows the clinicians to document in their own words while capturing the necessary clinical detail and billing codes behind the scenes. Like you can see on this slide, IMO data is used in the United States by around 89% of direct healthcare providers, 4,500 hospitals, and 70% of the US acute care system. Actually, we also have users all over the globe. A vast majority of clinical providers in the US use IMO content, and a lot of times they actually don't realize it because we are so seamlessly integrated into their electronic health record systems. We provide the foundation of clinically vetted terminology that is always current and meticulously mapped to the right codes. We are experts in the words and codes that describe patient conditions and treatments, from diagnosis to surgeries, labs, and medications, managing the complexity of around 5 million terms and mappings to all major coding systems across the globe. IMO's team of expert clinical terminologists also monitor and maintain terms and codes to keep up with all the regulatory coding systems, allowing our clients to confidently meet ever-changing regulatory reporting requirements. So as we go on to the next slide, so we all know that healthcare has a data problem, right? Clinical data and real-world evidence, it's often gathered from numerous disparate sources, and it's highly variable and prone to gaps. So at the point of care, data capture may be incomplete, and also, as per the statistics, unstructured data makes up around 80% of all healthcare data. And then this data may not be compatible with all other hospital systems or even other internal IT systems within an organization. So when information is exchanged between such disparate systems, it may result in data integrity compromise. And then add to it the aggregation within the data warehouse. There are endless opportunities for data to become inconsistent and inaccurate. And the ripple effects of these issues can then be felt across the healthcare ecosystem, impacting patient care, analytics, research, and more scenarios. Creating and maintaining clean and reliable data typically requires highly manual work that drains both human and financial resources. But a number of tools can alleviate this burden, and which is what we want to explore 3 such tools during our conversation today. So the first one is a data normalization engine that can standardize diverse clinical data into consistent and structured format. and then natural language processing or NLP technology, which can be used to extract insights from textual data such as clinical notes and research papers. And finally, a value set management tool, which can be used for accessing, creating, editing, and exporting clinically consistent value sets. So each section of our webinar today will delve into the key capabilities of these tools and various benefits of employing them. We will also try to end each section with some factors to consider before investing in or implementing these tools. On the next slide, so again, data quality management solutions extract, enrich, and structure clinical patient data across the healthcare ecosystem, making data more complete, consistent, accurate, and usable. So IMO precision normalized solution normalizes and adds standardized codes to data from multiple sources. And then the IMO Precision AI solution applies natural language processing to extract information from unstructured text and further enrich the data. And finally, IMO Precision Sets product simplifies the process of defining and managing clinically consistent patient cohorts and value sets. So I think with this, I'll now hand over to my colleague, Hao, to talk more about data normalization engine and natural language processing technology.
Thanks, Samantha. My name is Hao. I'm the product manager in the NLP space, but today I'll cover the data normalization engine part as well. So first, I'm going to talk a little bit about our data normalize process. This is the core component of a data quality management solution. So what is a data normalize engine? It is a piece of software that leverages a set of algorithms that can transform diverse data into consistent, structured, and standardized format. Normalization of clinical data is critical in healthcare, since clinical data like diagnoses, medications, procedures, and test results are often expressed in different formats or terminologies and with varied levels of granularity or accuracy. As just a couple of slides ago just has alluded to, that healthcare systems struggle with the quality, consistency, and cleanness of their data. So we're facing a data quality challenge. For one, provider documentation at the point of care is often subjective and highly variable, leading to inconsistency in patient data. And on top of that, data volume continues to increase. There are a growing number of health information systems and data sources, but each system may use a variety of data standards. This creates complications when standardizing information. In a recent survey conducted by IMO, we found that nearly half of the professionals that we spoke with from various organizations see data quality issues as a significant risk. A majorly 90% of the professionals acknowledge that they are facing financial losses due to poor data quality in either operations or rev cycles. This isn't really news to those in the industry. We're definitely aware of the challenges. We also need to consider about how medical codes are continuously updated. For example, maintaining accuracy in identifying the specific ICD-10 codes is critical, but this could be just the beginning. As we can see from the slide that on average, annual changes to the standard coding systems that will add, retire, will update hundreds to thousands of codes. Potentially, this can render the clinical data in our data warehouse outdated. And maintaining these code sets can be a daunting and very time-consuming task. In addition, different roles within healthcare may require different code sets. And it is really essential to listen to the clinicians and those who originate the data to understand their clinical intent. At IMO, we strive to provide the terminology that is designed to capture the clinical intent at the highest level of specificity. This data quality challenge is significant and ever-changing, affecting all aspects of data governance and various personas in the healthcare sector. We recognize these issues and the importance of providing a data normalized engine to address these issues. So, why to use a normalized engine? First, leveraging a normalization engine can simplify data maintenance, minimizing the manual task that can often introduce data errors and inconsistencies. And automating data standardization also saves time and human resources, which could in turn reduce avoidable costs. And that the standardized data created can be further used to facilitate faster or more accurate claims processing and to boost administrative cost savings down the road. And interoperability-wise, consistent, harmonized healthcare data enables easier data sharing and integration with other data sources. This more seamless exchange supports greater collaboration, communication, and also careful coordination within or across organizations. Plus, the cleaner, more consistent data derived from the normalization process improves data querying performance and produce more reliable database initiatives. As we all know, high-quality, standardized data is the foundation of countless initiatives. For example, reporting and analytics and the insights they reveal are only as effective as the data they start with. The same holds true for monitoring population health trends or identifying at-risk groups. Without clean and complete data, desired health outcomes will be elusive. Normalized data can facilitate clinical trials design or regulatory compliance, can lead to faster and more informed decision-making. And the same principle will also apply to the development of health IT solutions. Quality data input will lead to more reliable and trustworthy products. So far, we have talked quite a bit about the importance of data normalization, but what a data normalized engine really entails. Well, we think there are 4 key capabilities: cleaning, transformation, validation, and mapping. Data cleaning is to identify correct errors, inconsistency, and possibly potentially missing values in the clinical data. And data transformation is to reconstruct data into a consistent format, which often involves splitting tables and establishing relationships. And data validation is to ensure that data is accurate, complete, and consistent with the original records. And finally, data mapping, which is to match data elements to standardized terminologies in coding systems such as ICD-10, SNOMED-CT, or LONC. Here, let's take a sneak peek at our normalize engine. At IMO, we normalize disparate clinical data from diverse systems to a unified vocabulary called IMO lexicons, and then further map them to different code sets, allowing users to easily crosswalk between different coding systems. For example, let's consider a common condition like diabetes with renal manifestation. In different EHRs, they can be recorded in different phrases, such as DM both in lower cases with renal manifest, type 2, uncontrolled, or with individual words without a complete phrase. That could also come along with a unique code in SNOMED-CT or ICD-10. This is a common theme that we're constantly facing every day, that various input terms and codes for the same clinical concept will create confusions and hinder efficient data utilization. Now let's pass these different terms and codes through our normalize engine. These disparate data elements will then be normalized to a common definition and meaning, which is the uncontrolled type 2 diabetes with renal manifestation in IMO lexicons for this example. And this uniformity is then reflected across different coding systems, be it ICD-9 or ICD-10 or SNOMED-CT. Again, the importance of this normalization process is multifold. It enhances data interoperability across systems, improves documentation at the point of care, and enables accurate data analysis for better health outcomes. By leveraging our 30 years curation of terminologies, clinical intent at the highest level of specificity can be preserved and mapped to various code sets, all done without any laborious maintenance work on your end. Here are 2 more examples of normalization of clinical data in the lab and medication domains. I won't go into the details, but again, disparate terms and codes are normalized to IMO lexicals. In the first example on the top half of the screen, which is hemoglobin A1C measurement in this example, and then it could be mapped to LOINC, CPT, and some SCT. And in the second example shown on the bottom half of the screen, you can see that inconsistent medication data often coming into normalization engine without any medical codes. And after it passed through the normalization engine, it will be normalized and mapped to ARC's norm codes along with their corresponding term types. Now, recently with the emergence of large language models, I do want to bring this up that our clinical AI team at IMO are also in the process of implementing an LLM-enhanced normalized engine. I'm going to be very brief on how this is done. When a normalization process through our string match engine yields a low confidence score, the term will be redirected to our large language model engine for enhanced normalization accuracy. We have implemented multiple LLM techniques, including prompt engineering or retrieval augmented generation, RAG, and LLM agent to further enhance this normalization performance. Please stay tuned if you're interested in our future release of large language model enhanced normalized engine. There is a great deal to consider before investing in a new health IT solution or anything. Here are some of the factors to consider and explore, which might help guide your decision if you're interested in a data normalized engine. I think you shall define key issues and needs and have your stakeholders aligned. I definitely suggest that you have a clear and in-depth understanding of your health data requirements, such as, are you looking for a specialization or a generic normalization solution? And deployment and integration or security and compliance are definitely important aspects to weigh in as well. And how about scalability and maintenance? Some tools might get you going get-go, but leaves all the laborious code maintenance work on your plate. Or alternatively, the clinical informaticists and terminologists at IMO may be able to help you with all the coding system updates so that you can be maintenance-free and focus really on your real task. Please reach out to us if you would like to explore more on considering a normalized engine. Now, I would like to switch gear a little bit and focus on our natural language processing, or NLP. While a normalization engine excels in normalizing structured data or terms, we must also address the vast ocean of clinical notes, or the unstructured data that form the bulk of the patient records. Hence, NLP plays a vital role here. NLP enriches data by enabling the extraction of clinical information from free text and converting unstructured data to structured information. What is NLP? NLP is a subfield of artificial intelligence that really allows computer to understand and process human language. In healthcare, NLP focuses on extracting meaningful insights from textual data, such as clinical notes or patient records. And oftentimes, clinical NLP will also consume public data, such as research papers or public health data for extraction of insights. It is a well-known challenge in the realm of clinical data that a large percentage of clinical information exists in unstructured data formats. This vast amount of unstructured data leads to decreased accuracy or richness in data sets that can be used for insights and analytics. When data is unstructured, it's like having a library of books with no index. So finding the specific information you need becomes a really formidable task. Well, if you want to do everything manually, you can, but healthcare professionals will have to spend numerous amount of hours interpreting free text notes and reports, which could otherwise be directed towards patient care. As clinicians and healthcare professionals need to sift through a myriad of notes, reports, and records, clinical decisions will have to be slowed down. And more crucially, essential patient details might be missed or overlooked when they are buried in unstructured narratives which will result in impaired patient outcome due to the loss of valuable patient information. All what we have been discussing about is we need a tool to help us, which is natural language processing. NLP's capability to extract clinical and biomedical entities from free text, and then through a normalized engine to automatically assign standard codes to these entities, will enhance documentation while also reducing the burden of administrative tasks and potentially improve billing accuracy as well. By converting free text notes into structured data, NLP also makes this information easier to search, analyze, and share. When it comes to vast amounts of clinical data from diverse sources, NLP can reveal hidden patterns and trends to drive important discoveries. If ingested with different types of input data set, NLP can generate additional actionable insights, such as understanding patient needs and preferences, informing marketing research and product development strategies, or identifying potential trial participants. From an interoperability perspective, NLP can extract data from disparate EHR and health IT systems, creating a unified structured data and facilitate seamless data exchange and analysis. Now let's dive into the heart of clinical NLP, its key capabilities. First, we have entity extraction, or often called named entity extraction. Think of this as the ability of NLP to act as a skilled miner, extracting or trying to find precious stones from a rock bed. In our case, these precious stones are critical pieces of information, like problems, procedures, medications, or lab data, buried in the free text of narratives of patient records. This capability is foundational because it converts unstructured text into structured data that we can act upon. Then we have relation extraction. This is where NLP goes beyond just understanding the words in isolation. It starts to comprehend the relationships between them. For instance, a patient's assertion status needs to be accurately captured. This layer of understanding is crucial for a nuanced view of patient health narratives. Summarization is another NLP capability that can distill extensive clinical documentation down to their essence. It's like having a doctor or nurse read through the entire notes, all the patient records, and provide a concise summary, highlighting the key points that needs to be known. And finally, we come to coding. This is a capability where NLP will bridge with normalized engine to takes the extracted data and aligns with IMO terminology, and then further crosswalk to other standard medical coding systems. With all these capabilities, NLP bridges the gap between the rich, complex language of healthcare and the standardized codes that are necessary for billing, reporting, or analytics. Next, I'm going to quickly go through a couple examples of NLP processes so you can have a more visual understanding of the NLP capabilities that we just discussed. NLP process oftentimes start with the data pre-processing, including OCR, section header identification, just to name a few. Oftentimes, clinical data is stored in scanned PDFs and patient records, and then convert them into digital text. Once the text is digitized, we move on to the next pre-processing steps, such as section header identification. And this step is about really finding the structure in what appears just blocks of text in the patient records, in the notes. By identifying headers such as chief complaint, assessment plans, we can categorize and filter the information more efficiently. This organization of the text by section headers would also allow NLP to apply context-sensitive analysis to each section and reduce potential ambiguities in the text. Ultimately, the goal of data pre-processing is to have a clean and relevant free text ready for NLP extraction. And then here, this slide is about to show the named entity recognition capability. which is to really sift through the vast amount of unstructured free text to find medical key clinical concepts and group them by domains, whether that could be a problem domain or a medication domain or lab test domain or a procedure. On this slide, you can also see that these entities are displayed and highlighted in our nice user interface for enhanced visualization. So this slide is about relation extraction. This is only an example to show the relation extraction, to show the temporal information extraction. Our NLP system is capable of extracting a lot more relationships, such as body location of the problem or uncertainty of a diagnosis, or the test value of the lab test. And for medication, we have strength and dosage and route and frequency and all these information that can be related to medication. Again, relation extraction presents a key functionality in our clinical NLP that goes beyond the mere recognition of medical terms. It understands the relationships between them. For example, as shown in example here, we can see that NLP is capable of capturing the date as a temporal relation to the test result. And on the second sentence on the left, we also showcase how NLP can recognize the severity of the problem with the word severe being highlighted, along with the temporal occurrence this week to be associated with the problem. This contextual understanding is pivotal for assessing patient information. Here are some more examples to showcase our clinical NLP can truly grasp the nuances of clinical language. Clinical communications is often complex and laden with subtleties that can significantly alter your meanings. Our NLP technology is designed to navigate these intricacies. For example, negation is critical to the understanding of clinical narratives. A statement like patient denies something indicates that the absence of the symptom or disease. NLP must correctly interpret these negations to avoid false assumption or false positive about the patient's condition. Temporal information is another crucial element. Clinicians often document events and treatments over time, and understanding when something happens is essential. Just as shown in the previous slide, our NLP system identifies the phrase like a month ago or 3 months ago and correlate them with the frames with treatment or symptoms or anything we identify with NLP to provide a chronological understanding of the patient care journey. And also, as we know, clinical documents are often filled with acronyms and abbreviations. There are also common misspellings in the clinical notes as well. NLP ensures these are accurately interpreted, which is vital for accurate data extraction and patient care. Clinical documents often have ambiguities as well, and more precisely, the specialty-dependent language. Each medical specialty has its own lexicon. A term in dermatology may have different implications in surgery, and understanding the context within each specialty is crucial for accurate information extraction. Overall, grasping the nuance of clinical language by our NLP at IMO allows a deep understanding of the context and subtleties and ensure that the correct information is captured and being mapped to the most specific medical codes. For NLP, we also have compiled a comprehensive checklist of key factors that we think may facilitate your decision-making if you would like to implement an NLP system. First and foremost, we suggest that you have a clear understanding of what your needs and use cases. Do you want to focus on entity recognition or relation extraction, or both? What are the entity types you would like to extract? Can you leverage any current models, or do you have to develop and train a completely new model from scratch, which usually involves very time-consuming annotation processes? Do you also need to consume PDF as a starting point, or do you have clean text to work with? What are the downstream tasks once you have the NLP results? Does the downstream task have any implications on NLP performance, such as recall or precision? And does your organization allow the integration of large language models? With the emergence of large language models, there are lots of choices that you can have, which can further facilitate or enhance your NLP performance. But that all depends on if your organization is allowing these integration of the large language models. Then from a deployment and integration standpoint, how will NLP be integrated or hosted in your organization or product portfolio? What is your current tech stack? What are your scalability and cost requirements? And what about privacy and compliance requirements? Just to name a few of these important ones. But please reach out to us if you would like to explore more on considering an NLP system. With that, I think I'll hand it over to Mamta.
Thank you, Hal. So once the data is standardized using the normalized tool and enriched using the NLP tools, Hal just described, next step typically would be to identify patient cohort or report to patient registries, create management reporting, to name some of the scenarios. So to ensure all qualifying patients are identified during these steps, we need to be able to find accurate problem, procedure, lab, and medication codes required to filter the list of patients. So this is where a value set management tool can help. So on the next slide, before we continue this conversation, I would like to level set on what a value set is. What is the definition? So it is basically a collection of related terms or codes from one or more standard clinical vocabulary within the problem domain, procedure and lab domain, or medication domain that defines a clinical concept. So these codes are typically grouped together based on some inclusion and exclusion criteria. Value set is also sometimes referred to as a code group or a code set. In the EPIC world, it's referred to as a grouper, and within CDC, it's referred to as a case definition. So for this conversation, we use these terminologies interchangeably. So on the next slide, let's talk about what are the challenges within the value set creation and maintenance workflow. So we've had several conversations with our customers. We interviewed the market before we developed a solution for this space. And out of all the challenges we heard, three kind of stood out, right? The first one is standardization across organizations. So let's say there are multiple departments within our organization, and these departments have the need to create value sets. Most of the scenarios, the data analyst user persona within each of these departments is working in silo to create a value set as they receive a request. So over a period of time, even these value sets once created are not reused. Since they are working in silos, they are not kept up to date. So there is really no standardization across the organization, and these processes are extremely manual. And then when we go into the creation of value set itself, this process is manual again. So typically the user accesses code system browser, depending on what their use case is, ICD-10 or SNOMED, whatever it is, executes multiple search, collects all the search results into a document, and then manually goes through that list to ensure the right codes at the right granularity level are included in the value set. Once that's done, the process of collaborating with a clinician to ensure the accuracy of a value set is again manual, maybe email or via meetings or calls or whatever that is. And after all of this has been done and the value set is used within the use case, it just gets filed away, right? So over a period of time, there are so many code system updates. Typically, updating and keeping these value sets up to date is, kind of gets prioritized lower compared to all other high priority tasks these users may have. And over a period of time, it quickly gets outdated. Next time need arises for the same value set, the typical pattern that we have noticed is user go back and go through the same process all over again to recreate a value set. and hence adding duplicate value sets to whatever repository they have within their organization. So as we move on to the next step here, we've tried to kind of show the same manual nature of the workflow. Like I said, once a request is received, typically a data analyst user persona gets the request, and they, based on the request, the inclusion criteria, exclusion criteria, they execute multiple queries and gather a list of codes they think are accurate for the value set. And then, after they have manually gone through the list, collaborate with a clinician user persona, adjust the value set as needed, and file it away somewhere. And the whole process continues over and over as as these value sets get out of date and they need to be used again somewhere future down the line. So as we go on to the next slide. So the use cases for there are so many use cases for value sets wherever within the healthcare data filtering and querying process, you need to identify a diagnosis, a procedure, or lab results or medication. You need a value set to identify all the codes that need to be used within that query. So on this slide here, I've tried to capture some very common use cases. So within the population health, public health, and patient registries, value sets are used to identify precise patient populations and then improving targeted interventions and healthcare planning. So clinical decision support within the EHR, value sets can be used to set up or trigger alerts at the point of care, enabling healthcare professionals to make informed decisions as they are working with the patient. And then interoperability and meaningful use, as I called out earlier during the presentation, as we exchange data across multiple disparate systems, either within the organization or externally, it becomes really important to ensure the data exchange is consistent and to promote better communication between these disparate IT systems. Quality reporting and improvement. Here, value sets define the clinical measures and criteria to assess the performance and progress, helping healthcare organizations identify areas for improvement and implement targeted interventions for better patient care. Finally, in the payer space, value sets streamline the claim processing workflow, assess risk accurately, and then engage with members effectively throughout their workflows. Clinical trials, value sets are really crucial for precisely identifying the patient cohorts and study criteria, and then facilitating the recruitment process and ensuring that the trial results are reliable and applicable to the target population. So these are just some common use cases for value sets. There can be so many more as we engage with our customers on a daily basis. We see so many creative ways they use value sets within their workflows. As on the next slide, so what is a value set management tool? Based on the challenges that I called out earlier within the value set management and maintenance workflow, there are several attributes that make a value set management tool really very valuable to healthcare providers, users in the healthcare space. So a centralized software solution, typically web-based or cloud-hosted, where they can go, every user who has to use or create a value set across the organization can go and issue a search and see, is there a value set already created? Can I reuse that, or can I easily make a copy of that and tweak it to meet my needs for the existing request that I am working on? And on top of that, standardized, effective, and easy user-intuitive process to create a value set wherein you can ensure the value set is either granular enough or high level enough to cover for your specific use case, and ensure that no false positive or false negative patients are included in the patient cohort that you identify eventually. And then maintenance of these value sets over a period of time, as there are multiple code system updates, an easy process which you don't have to worry about, the amount of time spent to keep these value set up to date, and very easily, intuitively, you can keep these value sets up to date and ensure that at any given point in time, you can just go into this repository, access the value set, and use it within your workflows. The final criteria that I would consider there is democratizing the tool to a certain extent, where it doesn't have to be a specific user persona doing a specific activity in the value set maintenance workflow. Anyone who either needs or wants to create a value set can access the tool and with confidence create a value set that is accurate for their need. As we talk about this further, so what are the key capabilities then, right? So we've identified what should be within a value set management tool. So what are the key capabilities? So like I said, a cloud-based application which anyone within the organization can access, and a repository view where they can browse for existing value sets or search for specific value sets. And once they find it, they can easily load it into some kind of an editor and update it to maybe even, if I want to define intentional value set and my rules are at the SNOMED level, when I go into the output, I want to go granular and go to the ICD-10. So crosswalk between code systems like that and tweak the output of a value set to a granular enough level to meet your use cases. And then keep these value sets up to date at any given point in time. And finally, an easy way for you to export these value sets to be used within your downstream systems, where they have to be embedded into a query to identify patient cohort or quality metrics or whatever the use case is. In addition, if you're able to, when you adopt this new tool, if you probably already have several value sets or groupers that you have authored, if you can bring all of those in seamlessly into this tool and be able to maintain it over a period of time, that's what I would consider the key capabilities of value set management tool. On the next slide. So why use a value set management tool? Again, based off the challenges that I talked about earlier, this is a very manual workflow, right? Someone working on identifying the inclusion and the exclusion criteria and searching for all the codes, compiling that and going through that manually, collaborating that with someone to ensure that it is accurate enough, and over a period of time, keep that up to date. Or like I said, in today's world, it's so manual where they have to recreate again. It's a lot of human hours, and accuracy matters as well. So a tool which can help you do all of these things can save time, save resources, and even make the process very efficient for you. And then interoperability, irrespective of where you are using a value set, let's say diabetes type 2 mellitus, the definition remains the same. It is not dependent on who creates the value set and what tools were used to create and standardize these value sets. It is consistent across. And finally, the confidence with which you can use these value sets within your workflows and use cases, and be assured that the patients that you have identified are accurate. And, you are not inadvertently including a patient who should not be within that cohort, or missing out on any patients, and making sure that your value set, the quality of your value set reflects on the quality of the patient cohort identified eventually. How, if we can please go on to the next slide. Okay, so we used all these learnings when we built IMO Precision Sets tool, the value set management and the value set editor tool, the repository view that I was talking about. So on this UI, you can see that we have provisioned industry standard library that we download from websites like VSAC, NCQA, HEDIS. We ensure that these value sets are kept up to date, Any new releases in these external websites are reflected on our tool, within our tool, fairly closely. And then we also have a repository of IMO curated value set, which our clinicians have created and keep them up to date over a period of time. So you can use these two repository of value sets as your starter template. I mean, if you can use it as is within your workflow, sure, you can download it and use it within your workflow, or you can very easily load that into a value set editor tool, make a copy of it, tweak it to meet your criteria. And finally, the custom library, where you can import your currently authored value set and leverage the maintenance capability. And over a period of time, any variations that you create or any value set that you create from scratch will all be available in one place. Like you can see on this UI, you can come in here, execute a search based on the search terms, or maybe based on when it was created or who the user who created the value set or who last updated. There is various filter criteria available here. And once you find the value set, you can either use it as is or make a copy of it and use it within your workflow. So this is one of the aspects. And the second aspect here, this is what I refer to as a value set editor tool. You can search for codes within multiple code systems on one UI seamlessly. And then you can then create intentional value set, which over a period of time, if I have defined rules, like I want to include this nomad code with all the children, or I have defined my parent, within that parent, I want to exclude something with all the children. Over a period of time, as more codes are added to this hierarchy, the tool will automatically take care of keeping the output codes up to date for you. You don't have to come back and as new codes are available, go through this process again and add it to the value set. Intentional value set with these include with children, exclude with children rules will automatically take care of that for you. You can also capture the scope inclusion, exclusion criteria, and that can then reflect on your rules and your output codes. And then as we move on, after I've defined the rule, this tool automatically takes care of determining the output codes that qualify your value set. Not just that, it leverages the IMO mapping capability to crosswalk. Like I said earlier, if you were to write your rules using SNOMED codes, when you come into the output, you can then say, I want to include ICD-10 codes or ICD-9 codes within my output. Once you've done that, you can further go at the row level and exclude some codes if you don't care for those within your value set. So you can fine tune it and prune it to the granular level that is required for your use case. If you're casting a wider net, if you want the value set at a higher level, you can just leave it at the rules level and then just have the output reflect that level of information for you. You see also on this UI copy option at the top of the screen, which will very easily allow you to make a copy of this value set, tweak the rules, tweak the output, and create a variation, which can also be kept up to date over a period of time. As we can please go forward. Yeah, so this is the maintenance functionality that I was talking about. So let's say you have 100 custom value sets within your repository and the SNOMED 2024 release was updated to your environment. So the next time you log into the tool will identify all the value sets that have been impacted. First of all, on the repository view, it will give you an informational message to let you know 20 out of your 100 value sets have been impacted with the SNOMED release that was applied yesterday. Just with the toggle of a button, you can just see those impacted 20 value sets. And then when you click on it, the value set is loaded into the value set editor. And for the first step here, the tool tells you the extent of impact. It tells you how many codes were removed, how many codes were added, qualified, maybe because of the rules, or new codes were added to the hierarchy, whatever the scenario may be. It also tells you how many codes were retired and how many codes were modified. So when I say modified, what I mean is it had a certain description before and the description was updated. It'll give you that kind of information also. And when you click on the review updates, the UI is on the next slide. It gives you a side-by-side comparison of the state of the value set before and after the code system update. So you can go to every single row level. There are bulk actions available for you in this view, where you can select all the new codes that were added and take an action. If you don't want them within your value set, you can say remove. If you want to keep it, you can keep it. You can also add comments to indicate why you took a certain decision. If you decided that some codes have to be removed, why did you make that decision? That can be captured so that any other user who comes into the tool later on and wants to use this value set has a complete understanding of why the value set was authored a certain way. So after you've made all those updates, just by clicking a button, you can save that version to your database. This tool versus every single version of the value set gives you compare capability, where you can compare two different versions or two different value set. Let's say you had you identified an industry standard value set and made a copy of it. Over a period of time, industry standard value set has been updated. You can load it into the compare tool and look at the differences and consolidate. If there are new codes added, you can bring that into your local cloned version, or you can remove codes, whatever is required to keep that value set up to date. And there's also a download option. So you can download this value set into a Excel format. We also have, for Epic customers, we have VCG compliant text file format, which you can download and use with the Epic tools to easily import it into the Epic grouper editor, which will then surface within your slicer, dicer, EHR, and other components of the Epic EHR. Can we please go to the next slide? Okay, so that's about the value set management tool itself. Again, keeping in sync with the other two tools that we talked about, here is a helpful checklist of factors for you to consider before investing in or implementing a value set management tool within your organization. Like How said, if you have any questions or need more details, please don't hesitate to reach out to us. And also on our website, there is a PDF available, which kind of lists all these factors and checklists in a PDF, toolkit PDF for data quality, which you can easily download and refer to as well.
Awesome. Thanks, Hao and Mamta. All right, so now we're going to get into our Q&A session. So if you had any questions during this webinar or coming into the webinar, feel free to put them into the Q&A box. We do have a few questions already, so we'll go ahead and get started. This one I think would be good for Mamta. So can you explain how we might leverage pre-made value sets in addition to any custom value sets their team would create?
Sure. So when we reviewed the repository UI earlier, I showed you where we have, we download industry standard value sets from websites like NCQA HEDIS, VSAT, CMS ECQM, HL7 CCDA. It's all available to you within one repository. We also have IMO curated value set. So what this gives you is the ability to use out of the box value set or industry standard value set as a template to create a custom version for your organization, for your use case. So these value sets are kept up to date for you. Out of the box content value sets, they are, with every release, we ensure that they are up to date. So at any point in time, you can easily use these value sets as a reference, and just by a click of a button, make a copy of it and tweak it to meet your needs. So that's how these value sets can help you further cut down on the time required to create and keep your value sets up to date.
All right. Thank you. So how is IMO using artificial intelligence with its normalization and NLP offerings?
I see that there are two questions. One is, how is IMO utilizing artificial intelligence with its normalization and natural language processing offerings? And other questions, please comment and explain on how IMO clinical terminology is compared to and will play a role in large language model. I think these are kind of related. Maybe I'll try to, given the time constraint, maybe I'll try to give a little bit comment on And the second one, maybe hopefully it can also help answer some of the first question as well. So the short answer, like, can large language model replace IMO clinical terminology? And the answer is, of course, not. At least not until the point that we have maybe AGI. That so far we haven't really seen anything that, although despite large language model is really capable, has a lot of knowledge, even a lot of knowledge in the medical domain, but still it's far away from anything that can replace the IMO clinical terminology, which has been curated in the past 30 years. What we are seeing a probably future trend is really to combine these two. I think when you combine these two together, it really shines. The large language model still lacks a lot of the medical terminology knowledge that can be complemented by our clinical terminology, and especially the rules, the editorial policy behind these terminology. So the way how we use it, we think can improve this is there are multiple ways you can do that. First, you can just simply ingest some of the knowledge from the terminology side into the large language model by simply prompt engineering. You can put these knowledge as part of the prompt, and so provide large language model with some of the context, with some of the background knowledge, so that LLM can give you a better mapping, a better general answer regarding the terminology questions. That's one way. And another way is we really have a huge amount of knowledge on the terminology side. And sometimes providing all these information in one prompt seems to be a little bit more cumbersome. So at that time, you can create it's sort of like library. Typically, we call it vector store or vector database, that you store all these bits of information into the library, and then whenever you have a question about terminology, about mapping, about coding, and then you first kind of retrieve relevant information from that store, from that library, and then once you get the pieces, sometimes simple one piece would be enough. Sometimes you need multiple pieces, and then you combine them together, then feed into large language model. Again, you're providing more background knowledge, more context to the large language model. So combining this knowledge plus large language models kind of reasoning capability will give you a really optimal answer. And at the same time, we at IMO, we are also developing an IMO kind of fine-tuned, clinical terminology fine-tuned large language model. So please stay tuned if you're interested in this combination of clinical terminology with AI, with large language model in the future. I mean, this is definitely, we think, an area that will really lead us to improve performance or other, along with a lot of other benefits as well.
Awesome. Thanks, Hao. All right, so we're going to go ahead and close out for today. We hope you found everything useful in the webinar. If you have any questions or want a demo of our solutions, you can email our sales team at sales@imohealth.com. You can also go to our website and download our data quality toolkit at imohealth.com. And then finally, give us a follow on LinkedIn, Facebook, or X. We post a lot of great educational content every day. Thank you so much again for attending, and I hope you have a great rest of your day. Thanks, Mamta and Hao.
Thank you.
Thank you.